Hi all, this is Shweta Reddy working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. Today we are going to see about applications of restrictions to Maxwell's equation. So coming to applications of restrictions to Maxwell's equation, the other name is it can be also asked as general wave behavior along uniform parallel planes or waves between the parallel planes of perfect conductors. So now here we are going to consider EM waves propagating between pair of parallel perfectly conducting planes of infinite extent in y and z direction. So this is the diagram. So starting with the derivation, to study the behavior of electromagnetic field between two conducting planes, the procedure is to solve the Maxwell's equation. So the Maxwell's curl equations are del cross H is equal to sigma plus j omega epsilon into E, and del cross E is equal to minus j omega mu H. So between two conductors, we are going to consider sigma value as 0. So if we substitute sigma is equal to 0 in these two equations, you will be getting the 1 and 2 equations. After that, the electric and magnetic field equations. These are the equations which you have studied in EMF. So E is equal to ax vector ex of x comma y plus ay vector ey of x comma y plus az vector ez of x comma y and E of minus gamma z. And H is equal to a vector hx of x comma y and ay vector hy of x comma y and az vector hz of x comma y e power minus gamma z. Now we are going to consider e power minus gamma z in both the equations as 1. That is why, because we are going to substitute z is equal to 0. If we substitute z is equal to 0, e power 0 is nothing but 1. That's why it's happening as 1. After that, we are for rectangular coordinates, we can write this del cross h as ax vector, ay vector, az vector, dou by dou x, dou by dou y, and dou by dou z. And since it is an h, we are going to consider in three planes hx, hy, and hz. So in the previous equation, from equation 1, I can write del cross H is equal to j omega epsilon E. So I am going to write this. And after that, now in the previous equation, we have got the value for E. So instead of E, I am just substituting ax vector ex plus ay vector ey plus az vector ez and writing this same equation again. And after that, I am going to take the determinant value. So determinant value of ax is nothing but these two. Okay, so ax of del hz, I mean del hz, can you see del hz by del y and del hy by del z. And similarly, if I take ay vector, this first one and last one. So similarly, you have to do this. And az vector, if I take az vector, the first column and second column. First column and second column, and I have to cross multiply this. I know you know, I hope you know how to take the determinant value. And I'm writing the RHS part similarly. That is, I'm going to take this j omega epsilon e inside each and every term. So I'll be multiplying with each and every term and writing this RHS part. And after that, I'm going to equate this ax vector. I have ax vector in the LHS side as well as in RHS side. So I'm going to equate this ax vector, ay vector, and az vector. And if and I'll be marking that equation as 5. Now you have completed for H. Now similarly, you're going to repeat the same process for E. So del cross E is equal to ax vector, ay vector, az vector, del by del x, del by del by del by del z. And previously you had hx, hy, and hz. Here you will be having ex, ey, and ez. And similarly, from the second equation, del cross E is nothing but minus j omega mu h. So now whatever we did for H, we are going to repeat the same process for E. So instead of H, I'm going to write the value for H which we have got in previous equation. And similarly, I'm going to take the determinant value, and in RHS side, I'm going to multiply each and every term inside the bracket. I'm writing the RHS part again. And after that, similarly, what we did in the previous del cross H's, we have equated ax vector, ay vector, and az vector. Similarly, ax vector, I'm going to equate ay vector I'm going to equate, and az vector I'm going to equate, and I'm getting the sixth equation. So this is how I hope you understood. And I hope you know the wave equations are del square E is equal to del square E is equal to gamma square E, and del square H is equal to gamma square H, where this gamma square value is equal to sigma plus j omega epsilon j omega mu. So in the previous equation we had del square E is equal to gamma square into E, and in previously we had gamma square value also, that is sigma plus j omega epsilon into j omega mu. So for non-conducting mediums we have a condition for non-conducting medium sigma, sigma value is 0. So 0 plus j omega epsilon into j omega mu into E. And similarly for H also I am writing, and that is substituting the value of sigma as 0. And after that I am just multiplying this E inside. And after that, instead of this j square, I am going to substitute minus 1 and write this equation. Similarly, I am multiplying the H inside, and instead of j square, I am writing it as minus 1 and writing this equation. Next, what we are going to do here is I am going to expand this del square E in x, y and z coordinate. So if I expand this equation, I'll be getting dou square E by dou x square plus dou square E by dou y square is equal to dou square E by dou z square, and writing the RHS same as it, and expanding this del square H in x, y and z coordinate, I'll be writing the equation, that is dou square H by dou x square plus dou square H by dou y square plus dou square H by dou z square is equal to, and writing the RHS term as it is. And after that, you all know that the propagation constant formula is gamma is equal to alpha plus j beta. Since we don't have any attenuation, I'm going to substitute alpha value as 0. So gamma will be equal to j beta. And we have a condition, if alpha is real, beta will be equal to 0, means no wave motion and amplitude exponentially decreases. And also we are going to consider, let hy is equal to hy naught e power minus gamma z. So if I want to partially differentiate with respect to z, the previous equation, it will become dou hy by dou z is equal to this hy naught is constant, and if I partially differentiate with respect to z, minus gamma e power minus gamma z. So if I multiply this hy naught inside, I'll be getting minus gamma hy naught e power minus gamma z. I hope you understood this. So previously you have assumed that hy naught e power minus gamma z as hy. So you are going to just replace it by hy, and after that what you are going to do here is I am going to find for x direction also. So wherever you have y, just replace it by x and write this equation. Now we have completed for h direction. Now we are going to find for e. So Ey is equal to Ey naught e power minus gamma z. Now similarly you are going to partially differentiate with respect to z. So dou Ey by dou z is equal to Ey naught minus gamma e power minus gamma z. Now you are going to multiply that inside, and after that Ey naught into e power minus gamma z, you have assumed it as Ey. So you are going to just substitute it as Ey, and after that you have found for y direction. Now similarly for x direction, wherever you have y, just replace it by x. Now we are going to just assume that for y direction there will be no variation. So derivative of y will be 0. So in fifth equation, wherever you have derivative of y, it will be replaced it by 0. That's why 0 here, and writing the equation. In the second part, you will not be having any derivative of y, so you're going to write it similarly. And after that, in third part, here you had derivative of y, so replacing it by 0 and just simplifying it. I hope you understand. And after that, you have got 8th and 9th equation. This 12th equation is nothing but the previously obtained equation. You are going to substitute this 8th and 9th equation in this 12th equation. You will be getting 3 sets of equations, and I am going to mark it as 13, 14 and 15. Now similarly, you are going to take for 6th equation and solve the same process. So for y direction, then there will be no variation. So derivative of y will be 0. So you're going to take the 6th equation similarly. Wherever you have derivative of y, you will be replace it by 0. So first part will be replaced by this, and in second part there will be no derivative of y, and in third part you will be having derivative of y here. So you will be replacing the equation by like this. And now this equation 10th and 11th will be 10th and 11th you will be substituting in this 16th equation. If I substitute, this is what 16th equation is. These three things are there, right? This is 16th equation, and I'm going to substitute the 10th and 11th equation in 16th equation, and I'll be getting these three equations. Thank you all. We will see the continuation in the next coming video.